All right. So in here, we're going to talk about one thing in Algebra 2 that we've been asked before. But before that, let's talk about what happened here. Limit as x approach to infinite of a constant over x to the r. R is anything greater than 0. And also limit x approach to infinity of a constant over x to the r. Well, they are the same, so I'm going to change this. Negative infinity of x to the r is equal to what? So here's my question. If I have some type of constant on numerator, and I don't care about what kind of constant it is, it could be positive or negative, and the r is a positive power, and x to the positive power, so x could be 0.1 power, or half power, or 1/3 power, or 100 power, it doesn't matter what. If x approach infinity, what's the value I'm going to approach to?
Zero.
Why 0?
It's like a smaller and smaller decimal.
Right. Zero. So let's just point out something that's very obvious. Just like 1 over x, we don't even take any constant. We just take constant 1, and we just do x to the 1 power. Now, I'm going to do, if I do a t-chart, x, y, right? If I put it 0.1, if I put it, let's say 10, it's going to be 1 over 10, that's equal to 0.1, right? If I put 100, it's going to be 1 over 100, that's 0.01. If I put 1,000, that's going to be 1 over 1,000, that's equal to 0.001. So as I'm approaching a bigger value, so if I say limit x approach infinity of 1 over x, that's always equal to 0. Because as x approaching, that 1 becomes insignificant. So it becomes going to 0. Now here's my question though. What happens if we limit x approach infinity on 9 billions? Right? I don't know how many 0 is billions. I'm assuming I'm right. Let's say x to the power. If I approach infinity, what happens?
The same.
Slate, what do you think? It's going to be the same. It turns out 9 billions is just a number, right? It doesn't matter what kind of constant. I can place a very large constant. But if you compare to infinity, it's no comparison. It's no comparison, right? It just, you cannot compare because 9 billion over infinity is still going to go to 0. And that's one thing you have to understand. It doesn't matter what the number on the top. It doesn't matter. As long as x to the positive power on the bottom, it's always going to go to 0, regardless of what happened. Because infinite is a very, very large number. It cannot be described. Compared to 9 billion, that's nothing. Right? That's nothing. So that's the first part of understanding. Do you guys understand that part? Okay. I'm going to talk about one more thing. What is a horizontal asymptote? You have to be able to ask this question. On AP exam, they love this question. How to find horizontal asymptote? Let's say how to find horizontal asymptote. Basically, it's limit x approach infinity of f of x. Now, when it reach infinity, it's gonna give you, if it give you a value, and that value called L, the L is some type of constant, then that's gonna be a horizontal asymptote. So the idea of if you reach infinity, that's gonna give you the idea. So we're the horizontal asymptote. I'm gonna give you an example. In algebra 2 and pre-calc, we actually give a question like this. Let me go find the question though. Give me a second. Do you guys finish copying? Okay. I'm gonna look at this question in particular. Let's see if I can find it. Oh. let me see, limits as x, oh, sorry. I'm going to say f of x is equal to, let me check on decimal, so the function is, okay, is 2x squared plus 3x plus 1. 2x squared plus 3x plus 1. And is a 5x squared plus 3x plus 1, I think. Yeah. Okay, do you guys know the horizontal asymptote of this? As9 says yes. Where's horizontal asymptote? How do you know it's 2/5?
Because I think it's like if the exponents are the same, the top one divided by the bottom one, the leading exponent. And I think it's if the top exponent is greater than the bottom exponent, I think it's 0. And if it's other way around, I think it's non-existent.
Who told you that?
Mr. Sparrow.
Very good. See, Shaparo, very. So I love Shaparo. He's an awesome teacher. Olympia should never push him out, but I think he's a very, very good teacher. So if you pay attention to his class, is you look at the coefficients. Well, the problem is you're going to compare the degrees. So this is the highest degree of bottom and top and bottom, x squared and x squared. So if you compare x squared, if they are the same, the coefficient is going to be a horizontal tangent, a horizontal asymptote. I'm sorry, horizontal asymptote. Does that make sense? Okay. But why is that though? So in pre-calc and algebra, we ask you to memorize that. In calculus, we're going to investigate. So there's a difference between calculus and pre-calculus. Pre-calculus, we just ask you to memorize the fact. So anything to the 0 power is 1. Now we're going to investigate why that is equal to that way. So I'm going to show you how to use math to help you. So let's just say if I have f of x. Now, always look for, this is the part that you have to be very, very paying attention. Pay attention to the degree of denominator. What is the degree of denominator in this case? Highest degree, sorry, highest degrees. Highest degree in denominator. What's the highest degree in denominator here? What is it? 2. 2 would be x squared, right? So that was the highest degree. So I'm going to take this function. I'm going to say limit as x approach to infinity. Remember, we want to find horizontal asymptote. We must x approach to infinity. And we must take a 2x squared plus 3x plus 1 all over 5x squared plus 3x plus 1. So in order for me to find a horizontal asymptote, I want to reach to infinity. And not only that, I'm going to take that, I'm going to divide it by highest degree of denominator. Why is the highest degree of denominator? You're going to see in a second. This will cancel out. Left with 2 plus 3 over x plus 1 over x squared over 5 plus 3 over x plus 1 over x squared. What happened x approach infinity on each individual things? Which one's equal to 0?
3 over x and 1 over x squared.
There you go. They're all equal to 0. Now what's left? 2 over 5th, right? Very, very important. 2 over 5th. Now, according to the thing, they say you have to do two things. You have to do this first, and you have to do the second. It turns out the second one is going to be exactly the same. Because if I approach negative infinity of 2x squared plus 3x plus 1 over 5x squared plus 3x plus 1, I still divide it by highest degrees. But it doesn't matter if I divide it by highest degree here because it's divided by x squared here. It's still limit x approach to negative infinity of 2 plus 3 over x plus 1 over x squared over 5 plus 3 over x plus 1 over x squared. So it doesn't matter if I reach infinity or negative infinity, because 1 over negative infinity is still going to go to 0. Am I confusing you? 1 over negative 100, 1 over negative 1,000, 1 over 1 billion, negative 1 billion, it's still going to 0, but it's in different way of approaching. One is approaching from the positive end, one's approaching the negative end. They're still going to go towards 0. So therefore, it's equal to 2 over 5. So two direction. You're going to say 2 over 5 is your horizontal asymptote, and 2 over 5 is your vertical asymptote, horizontal asymptote on the left and on the right. Now, with that being said, let's show you the graph. Let's show you this graph. And let's show you what the asymptote is. Do you see the asymptote? It's never reached that value. Do you see that? You can get so far away and it looks like it's very close to it, but you'll never reach it. And if you ever have a question about asymptote, ask Ron Grudge. He'll explain to you how asymptote works. And on this side too, look on this side, on the left side too, negative infinity also on the left side, right? Now here's the problem what people have. What do you see? What kind of problem you see? Yes, Amir? A crossing asymptote, right? And you're like, wait, I thought asymptote is like Ron Grudge relationship, right? You never reach there. And by there, it's actually touching. That doesn't make sense. Okay, so here's what I will tell you. A very easy way to determine this. A vertical asymptote, and please don't get me canceled for what I say. But I'm gonna give you an analogy so you can understand. Trust me, it's educational purpose. A vertical asymptote is like you're for sure gay. Like you're born to be gay. You're just gay. There's no way for you to touch them. Like if you like that boy, sorry, that boy is for sure gay. You don't have a shot at it. Doesn't matter how I don't know which girl I want to make fun of. Doesn't matter how cute that boy is, Elena didn't have a chance. Right? Sorry, Elena. Sorry. So because he's just for sure gay. It's like a vertical asymptote. Now a horizontal asymptote is kind of different. It's kind of like they're undecided. So they in like somewhat in middle region or between their 15 to 30, they can experience a girl or boy. I mean, they can be bisexual at one moment and change into to gay eventually. So vertical asymptote is still gay, but it's determined later. That's a horrible analogy, right? Yes, feels like you can stand that. Okay, so that's a way kind of think about it is horizontal asymptote. It didn't matter. Look at the definition of horizontal asymptote. The horizontal asymptote, they only care about when x approach infinite. X approach to, I'm sorry, this one's negative infinite. It's either positive infinity or negative infinity. What happened eventually, right? Are they eventually gay? It's pretty much horizontal asymptote is eventually gay, but a vertical asymptote is for sure gay. There's
Is the horizontal asymptote defined?
it will be defined eventually. You will define to a value, right? So that's a probably one thing to put it as, right? So yeah, so yeah. I just had somebody explain to me what is don't say gay bill. I don't care about your sexuality. It's none of my business. I just use as an analogy. Yeah. So instead of call somebody gay, you call them vertical asymptote. You can tell the parents, yeah, he's vertical asymptote. Write that on your notebook. Okay. There you go. Sorry, I think life's too boring. You gotta make fun of everything. But don't get offended if you are gay. I don't really care. What'd you say? Okay. So what happened if let's check out this situation though. Let's check out 3x squared plus x plus 1 over 4x to the third plus 2x plus 1. And where's the horizontal asymptote of this case? Is there any horizontal asymptote here?
Is it zero?
Why do you think it's 0? And what Asana says, right? So let's pay attention what Asana says. Asana says, I think Asana says it's opposite. He says bigger on the top is 0, but it's actually bigger on the bottom is 0. One student of mine, I think Jinju just left here. She said something about Beyonce, which is pretty funny. So she said it's a bigger on bottom is gonna be 0 because of Beyonce. B-Y-O-N, the O. How to spell Beyonce? B-Y, how to spell Beyonce? Seriously, I don't know. Like B-E-Y-O-N-C-E? Okay, so if bigger on the bottom is gonna be 0, that's how you determine that things. Yeah, so that's what she told me. I don't know. I'm just refer from a student. I learn stuff from student all the time. I thought it was pretty interesting. So in this case, you're gonna limit x approach to infinity, right? Of 3x squared plus x plus 1 over 4x cubed plus 2x plus 1. What is the highest degree on denominator in this case? No. 3. So limit x approach infinity of 3x squared over x to the third plus x over x to the third plus 1 over x to the third over 4x to the third over x to the third plus 2x over x to the third plus 1 over x to the third. You're going to realize that it becomes very repetitive. You can see it right away. That's almost 3 over x plus 1 over x squared plus 1 over x cubed over 4 plus 2 over x plus 1 over x cubed. Does that make sense? What happened when they reach infinity? Well, this part is going to give you what? 0, right? Does that make sense? That part is going to give me 0. That part is going to give me 0. 0 over 4. Guess what? It's 0. Now you're going to be like, well, I'd much rather to memorize what Shapiro told me, because Shapiro only tells me if bigger on the bottom is going to the 0. It's true. It's not wrong. And if it's same degree, just take a coefficient. But what if the numerator is greater though? Well, let's just say, just to give you an example. What about f of x equal to 3x squared plus 1 over 2x plus 1? Is any horizontal asymptote here? Remember, x approaching infinity, that's how you find horizontal asymptote. So 3x squared plus 1 over 2x plus 1. What's the highest degree on denominator in this case? Just x, right? So I'm just take it divided by x. And that's equal to limit x approach infinity is 3x plus 1 over x over 2 plus 1 over x. You know this is going to 0, this is going to 0. On the bottom is 2. What about the top? What about the 3x? Well, I'm going to plug in infinity, right? So it'll be 3 times infinity, right? Now, I probably have $2 in my pocket, but compared to 3 Bill Gates, 3 Bill Gates is way over me. So that 2 is insignificant. That becomes going to infinite. If it goes to infinite, if the function go infinite, that means it goes straight up. If it goes straight up, does it have horizontal asymptote? No, because the function just goes straight up. It's not plateaued into a value. So this case is for sure not gay. I don't know. So we give you 3 situations. One situation if they're the same degree, but I want you to see the math of it. Divided by highest degree on denominator, it's a reason why that's that way. Yes.
So the horizontal asymptote for the last would be infinity, or it doesn't exist?
It's no horizontal asymptote. Now that comes down to an interesting case. This is an interesting case. What is the horizontal asymptote of this function? This becomes a very interesting case. It turns out you have to do exactly what I say. How do you find horizontal asymptote again? Something to do with limits.
Limit x approaches infinity.
Limit x approaches infinity. Does everybody understand that part? Yes.
For it to be horizontal asymptote, does it have to be the same for negative infinity and positive infinity?
It don't have to be the same. Sometimes you can have 2. Okay. So limit x approach infinity. What is the highest degree on denominator in this case? Just x. Now be careful how things work now. Limit x approach infinity. 4x squared plus 3 over 3x plus 1. On the bottom, you're going to divide it by x. Does that make sense? How about inside a radical? You're still dividing by x, but what's inside a radical? You divide it by what? Is it x? Why x squared? Why somebody say x squared? Right. Square root x squared is equal to not really like x. It's actually absolute value x, to be honest. It's negative x on the left side and positive x on the right side. And that's what is you have to be careful. You divide by x squared here, divide by x squared here. Then it will be limit x approach infinity of 4, right? X squared cancel out, plus 3 over x squared over 3 plus 1 over x. What will happen here and what will happen here? That's equal to 0, right? So it'd be square root of 4 over 3. And that's equal to 2 over 3.
Horizontal asymptote doesn't restrict it. Then what's the point of it?
What are you talking about? Like, what do you mean?
It's like it crosses it. It crosses the asymptote.
Yeah, but if you look at definition of horizontal asymptote, they don't care about what happened in the middle. It only happened what happened at the end. Like they don't care about if you experience different life at between 15 and 30.
What's the point?
It just, yeah, are you eventually gay or not?
So
I think that's like a very bad way of saying it, but it's kind of you see that happen. He's like, okay, now I'm this age, I just, this is what my, and there are a lot of people marry, and then they end up divorced and they become gay.
what Neil said, if you approach positive negativity, they don't have to be the same.
They don't have to be the same because in this case are the same, but in this case it's not. I'm going to talk about what happened when they reach negative infinity. If they reach negative infinity about this, now the reason why the process is going to be the same, but here's the thing that's going to be a slight different. This one's going to be x squared, this one's x squared, like this, and this one's x, and this one's x. When they reach negative infinity, it's going to be 4 plus 3 over x over 3 over x squared, 3 plus 1 over x. This one's going to go to 0, this one's going to go to 0. However, if we're approaching negative infinity, this one end up being negative. Now, this one is kind of hard to figure out. Why is that negative? It turns out they are two horizontal asymptotes. And this one's a negative 2/3. And they are two horizontal asymptotes as opposed to one. Why? Remember we talked about square root x squared is equal to, square root x squared is equal to absolute value of x. Absolute value of x on the right side is x. On the left side is negative x. Therefore, on the left side, it's going to provide you a negative part of the answers. You can just memorize it. Radical usually have a positive and negative. That's a quicker way. But for you to understand, is you have to understand square root x squared is equal to absolute value x. On the right side, it's going to be x. On the left side, it's going to be negative x. That's why when we would reach negative infinity, you're going to have a negative value to it. And let's see if this is true. Let's see if this is true. Okay, let's see if this is true. Let's go check it out. What was the equation again? Square root of something. 4x squared plus 3 over what? Okay, let's pay attention to this one. So you see here, x equal to what? 2 over 3? I mean, not y. Y equal to 2 over 3. See that plateau? Even though, look, it crossed. I don't care what happened in the middle region. I only care about what eventually is. Okay? Eventually, you see the line is going toward the purple line. It crossed and come back toward the purple line. Do you see that? How about the other side? Well, the other side has another one. Y equal to negative 2, 3. This one never cross, but again, go to negative infinity. It looks like they're touching, but if you zoom in enough, the green line never cross the black line. So therefore, there was two horizontal asymptote, which is one is at 2/3 and one is negative 2/3. But that only happened on a radical because radical has two of them usually. There's a positive one and there's a negative one. Not only in a radical, it can be absolute value x over x plus 1 as well. This one's really easy. What do you think those two at? If I have f of x, where's the horizontal asymptote at? Well, when the limit x approaching infinity, which equation I'm going to be using? The positive x or negative x? So it'll be x over x plus 1, right? And divided by x on one of them is going to 1. Does that make sense? What happened limit x approaching negative infinity? Which equation I'm going to be using? There we go. and that's equal to -1. So there are two horizontal asymptote in absolute value as well. Does that make sense or no? Am I going too fast? Yes, Phil? You got it? Because in negative infinity and positive infinity, they are two different equations. If you reach infinity, you still divide by top and bottom by x. I just didn't show you how to do that. But you can look at the degree as well. That's just equal to -1 and what equal to +1. So that's why in absolute value and this had two separate ones. Yes. Because if I approach infinity, just look at the coefficient or divide by top and bottom by x. If I divide by top and bottom by x, it's going to be 1 over 1 plus 1 over x when limit x approach to infinity. This part is going to go to 0 and just going to be 1 over 1. Did that answer your question? Got it? How much time I have? Now it's 1:20. What time we get off? 1:24. I want you guys to think about this one, but this one's kind of hard. And this one's, they loved this equation. Hold on a second, -3. Horizontal asymptote on this particular case it's kind of hard to understand. Now I want to explain this case where is e to the x graph first. Do anybody know what the e to the x graph will look like? It intersect at 1, sorry. And it's gonna grow like this. But there is an asymptote right here on the left side. Limit x approach to infinity of 3e to the x plus 4 over 2e to the x minus 3. What happened if I reach infinity? Just plug in and see what happened. 3e to the infinity plus 4 over 2e to the infinity plus or minus 3. Or divided by highest degree, which is e to the x. You're going to see something happen. But let's talk about this. Just looking at this, what do you see? What do you think the final answer is going to become? Is a 4 significant compared to 3 to the infinity power? Is a -3 is significant? No, so they are technically just cancel out, right? But if you want to reach infinity, that's fine. 3e to the x over e to the x plus 4 over e to the x over 2e to the x over e to the x minus 3 over e to the x. This cancel out. That's going to be 3 plus 4 over e to the x over 2 plus 3, 2 minus 3 to e to the x. When limit x approach infinity, what will happen here? What would you get? 3 over 2. And that was pretty easy. The last part is the hardest part. What happened when they reach negative infinity? Now, it turns out on this one, you have to understand the graph. You cannot use a traditional mean to find out the answer. So let's reach negative infinity on e to the x. What do you think is going to become if e to the negative infinity?
-4 over 3.
Yeah, this one's going to be 3 to the 0. Why? If you think about e to the x graph, it's going toward here, it's going towards 0. Plus 4 over 2 times 0 minus 3 is equal to 4 over -3. And they are two separate answers, 3 over 2 and 4 over -3. And there's two horizontal asymptotes. Now, the things about this, you have to understand this graph. This graph is useful. But meanwhile, you just have to understand the first few. You have homework about that, not too much. It's pretty easy. If you understand pre-calc, then you understand this. Hopefully, I'm not offending anybody. I'm just using as an analogy. I thought I'd give you back. No, I don't need it back. I'll record the score. No, I don't allow to pass back tests. I want you guys to figure out what you did wrong.
Oh,
If I give it back, people's gonna
yeah, I
compare.
forgot about the homework.
Yeah.